All right, Big Ideas Algebra 2, Chapter 9.1, Right Triangle Trigonometry. So we're going to be able to evaluate trig functions of acute angles. Remember, acute angles are anything less than 90 degrees. We're going to find unknown side lengths and unknown angle measures of right triangles using those trig functions. And then we're going to use those trig functions to solve some real world problems when they're in right triangles. So some new terminology and some new variables that we're going to introduce. So typically in algebra, whenever you solve for a missing variable, you'll usually see the letter X. When dealing with trigonometry and more specifically angles, an acute angle is going to be represented by the letter theta. It's a Greek letter in the Greek alphabet. It kind of looks like a zero if it's italics and then has a horizontal line through it. So that's a capital letter theta. And then labeling the three sides of a triangle are also really important terminology to get used to for right triangle trig. So you always have your hypotenuse, which is opposite of your right angle. So since everything's right triangle trig, find your right angle. The longest side, or the side that does not touch your right angle, is the hypotenuse. Then in relation to where your theta is, you have a side that touches it, and then you have a side that doesn't touch it. So the one that doesn't touch is the opposite. So notice how this theta does not touch the opposite side. That's why it's called the opposite. And then whatever your leftover is, since you got three sides, the last one's called your adjacent. So you're going to use these three labels to help define the 6 trig functions. And here is what they are completely spelled out. So they are sine, cosine, tangent, cosecant, secant, and cotangent. When looking at a calculator, you're not going to see the entire words spelled out. You'll see them as 3-letter abbreviations. So please do not say the word sin of an angle. It is sine. It is labeled SIN for short, but when we're speaking it and listening to it, we're still going to say sine. And then again, same thing, don't say cos, it's cosine. Tan for tangent, CSC for cosecant, SEC for secant, and COT for cotangent. So when writing them out, you can use the 3-letter abbreviations, but verbally, we're going to speak out the entire words: sine, cosine, tangent, cosecant, secant, and cotangent. So here are the following ratios that you are going to use to set up your side lengths to find the said missing angles. So the ratio for the sine of an angle is equal to the opposite side divided by the hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then the following 3 are the exact same as the ones above, but they are just flipped, or they are the reciprocals. So instead of right here, we have opposite over hypotenuse, you just flip it to put hypotenuse on top. Same thing with secant and cotangent. So those abbreviations of the opposite, adjacent, and hypotenuse are used to find the lengths, and then they're reciprocals of cosecant, secant, and tangent. One thing that may help you remember the order of how you do sine, cosine, and tangent is this SOHCAHTOA. SOHCAHTOA is an abbreviation that is going to help you remember the order of each one of your trig ratios. So notice those first 3 letters are SOH, that is sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent is opposite over adjacent. So you're going to hear me or other teachers or even your classmates say the words SOHCAHTOA a lot. So let's look at our first example. So we're going to evaluate the 6 trig functions using the perspective of our angle theta with the following triangles. So we have the number 5, the number 12, and our hypotenuse. So using the Pythagorean theorem, we can determine what the hypotenuse is with our a squared plus b squared equals c squared. A and b are your legs, or the sides that touch your right angle, and c is your hypotenuse. So you can plug that in and get 5 squared plus 12 squared, and then your c is going to be the square root of 169, which is equal to 13. So that's the length for your hypotenuse. You can go ahead and label those. 12 is your opposite side because it does not touch your theta. 5 is the adjacent because it's next to it. And then the hypotenuse is 13. So sine, remember, katoa, sine is opposite over hypotenuse, which is 12 over 13. And you're going to leave that as a ratio or as a fraction. Cosine is going to be adjacent over hypotenuse, 5 over 13. You plug in your number values. And then tangent is going to be opposite over adjacent, which is 12 over 5. Now for your cosecant, your secant, and your cotangent, remember it's just the exact same thing, but the reciprocal. So you're going to take what you have above it and just flip it. So instead of 12 over 13, 13 over 12. Reciprocal for secant is 13 over 5, and then reciprocal for cotangent is 5 over 12. So those are your 6 trig ratios or your trig functions of that angle in this right triangle. Now, using this to evaluate missing ones when you're already given one value is going to help if you draw a right triangle with one of your right angles, theta, as your acute angle, that's your perspective angle, and then plug in your 4 and your 7 based on what trig ratio that we're using. So since we have sine is equal to opposite over hypotenuse. So that means that 4 is going to be opposite of your theta, and 7 is your hypotenuse. Now, some people could have drawn their theta up here, and then your 4 would be down here, and then your 7 would still be the hypotenuse. That's okay. Everything is all in perspective of where your angle is. So we have a 4 and we have a 7, and now we have to find the length of the missing side. Again, we know our Pythagorean theorem of a squared plus b squared equal to c squared. So when you plug that in, 49 minus 16 gives you 33, and then you can leave that in radical form. So finding the values of the other ones, again, you're just using SOHCAHTOA. You already have sine, so the next one would be cosecant, so you just would flip that, would be the next easiest. Then everything else is going to use your square root of 33. So cosine is adjacent over hypotenuse, square root of 33 over 7. Tangent is opposite over adjacent, so you have 4 over square root of 33. And remember, you cannot go around with your radical down, so you must multiply by the conjugate. So you multiply the top and the bottom by square root of 33 to make that a rational term. So you can look that up as rationalize the denominator. Secant is just the reciprocal of cosine, so you would flip it. Again, you can't go around with your radical down, so you need to multiply to rationalize it. And then cotangent is to flip adjacent over hypotenuse. You can have radicals on top. Those are okay. You just cannot have radicals in the bottom. All right, so with special right triangles, ones that you'll see more often, and we'll kind of touch base on this later when we look at the unit circle. So 2 right triangles that are called special right triangles are 30, 60, 90s and 45, 45, 90s. So this first one right here, that's a 30, 60, 90. The ratio of sides in a 30, 60, 90 is the short side is always half of whatever the hypotenuse is. So since your hypotenuse is 12, half of it is 1. Let's say this hypotenuse was 6. In a 30, 60, 90, your short side would be 3. And then the relationship between your short side to your long side is just to multiply times the square root of 3. We could go into proofs for about that, but it involves drawing a second triangle next to it. And then being able to use Pythagorean's theorem to find that missing one where they're all an equilateral triangle of 2. Same thing with the 45, 45, 90. So 45, 45, 90 is an isosceles because your base angles are congruent, which means your legs are congruent. So you can use Pythagorean's theorem. 1 squared plus 1 squared is 2, and then you take the square root of 2, and that's why you get your hypotenuse of 2. So using your sine, cosine, tangent, cosecant, secant, and cotangent ratios, really you need to familiarize yourself with sine, cosine, and tangent of 30, 45, and 60. And it's going to help you a lot more with the unit circle, which is something that we'll go over towards the end of this unit. But in a 30 degrees, here's your perspective. Sine is opposite over hypotenuse. 1 is your opposite, 2 is your hypotenuse, so that's why it's 1 over 2. Cosine is adjacent over hypotenuse, so you got square root 3 over 2. And as you kind of notice some relationships, notice how the sine of 30 is equal to the cosine of 60, because you're looking at the same triangle, but the perspective of your angle changes on which side is opposite and which side is adjacent. Cosecant, secant, and cotangent, remember, you're just flipping, or you're getting the reciprocal. So you take your 1 over 2 to flip, you get a 2 over 1 right here. You flip your 2 over square root 2, and then you would just have to rationalize everything from there. All right, so looking at a 30, 60, 90, and finding a missing value of a right triangle where you do not know the other two sides. So 30 is your perspective angle. You know that 8 is your hypotenuse, and x is your adjacent side because it's touching. The ratio for adjacent over hypotenuse is your cosine. So you're going to take the cosine of 30 degrees, and remember that chart that we used earlier. Cosine of 30 is the square root of 3 over 2, so that's what we're going to plug in here for cosine of 30. And then you just have a proportion that you can cross multiply and solve. So 8 square root of 3 divided by 2 is 4, and that equals to your x, so that is the distance of that leg. If you round it to the nearest hundredth, 6.93 approximately. All right. Again, continuing to find some missing sides. Solving your triangle ABC means you're finding every single angle measure and every single side length. So because it's a right triangle, you know that angles A and B both have to add up to 90 because the other 90 gets you to 180. So you can find that by taking away 90 from 28, or if you feel more comfortable taking away 180 from the other two, then you can do the same thing. So angle B is 62 based on your supplementary rule. Then you can use your trig functions. One that involves the ratio of A and B, and then one that involves B and C. You don't want to use A to find C after you find it, just in case you make a mistake. You don't want to compound that mistake. So use as much information as you're given in the problem that you can the first time. So solving for A and C first is opposite over adjacent with your A and B ratio. So you would have tangent of 28 equal to A over 15. Again, multiplying both sides by 15. And in a graphing calculator, you can type in the tangent of 28 degrees and it will give you a rounded estimate, or it will give you a whole bunch of decimals. When you take that number and multiply times 15, it'll give you a number that's close to 7.98. And again, those are just things you type into the graphing calculator. You hit 15 times tan 28, close your parentheses, enter, and that will give you the number of 7.98. So now in order to look at your hypotenuse, you know that secant is the ratio that's adjacent and hypotenuse where it's on top. You could also use cosine, but that would put your hypotenuse on bottom. Typically, it's easier to solve these problems if you put your variable on the top. So that's why you use secant. And again, there is a button on the calculator that uses secant, or if you don't see it, you can just take the flipped reciprocal, which is 1 over cosine, and typing that in gives you 16.99. So you now have all three values of the sides and all three values of the triangles. So when you see solve for triangle, that's what you're looking for. Make sure you got all three angles, all three sides. All right, here's your real world problem. So you're hiking near a canyon, and while standing at this point A in the diagram, you determine that you have a perpendicular line from your 2 mile distance here all the way over to the other side for your point C. So you have a right angle. You then are going to walk the distance from A to B to determine that it is 2 miles, and then you find that that angle measure is 76 degrees between A and C. You then need to determine what the distance would be if you were to go from point A to point C. So how wide is the canyon is what your question is asking. Based on the diagram in the picture, these are both legs. So from the 76 perspective, your x is the opposite, your 2 is your adjacent. So then you would just multiply both sides by 2. In the calculator, 2 times tangent 76 equals 8. 8 miles.